Chemical equations are widely used to show what chemicals react to form particular products, but they don't show how this happens. Reaction mechanisms fill that gap by using curly arrows to show how reactions happen step by step. And in this video, we're going to learn exactly what reaction mechanisms are and how to use curly arrows correctly when drawing them. So just what are reaction mechanisms? Well, scientists use reaction mechanisms to show how chemical reactions involving organic compounds occur. They break chemical reactions down into a series of steps or stages and show the movement of electrons during the reaction. Mechanisms allow us to see which bonds are being broken, how new bonds are being formed, and in some cases, the intermediary species that are formed along the way. And although they can look intimidating and complicated to begin with, getting your head around the foundational principles now will mean that when you come across specific reaction mechanisms in the future, you'll be able to start making sense of them straight away. And the key to understanding mechanisms is knowing what the curly arrows are representing and how to draw them correctly. Curly arrows are used to show the movement of electrons during a chemical reaction, which although doesn't sound too exciting, it is at the heart of every chemical reaction, from the combustion of alkanes to the oxidation of alcohols. And you can see both of the arrows in this reaction mechanism are double-headed. And that's important, because that means they're showing the movement of a pair of electrons, and that could be 2 electrons from within a covalent bond, or 2 electrons from a lone pair. So does that mean we can only represent the movement of pairs of electrons? Well, no. It is possible to show the movement of individual electrons using single-headed curly arrows. For example, during the homolytic fission of bromine, each electron from the bond goes to a different atom, forming 2 bromine-free radicals. However, AQA don't expect you to know or use this notation. The reaction mechanisms you'll cover during the course of A-level chemistry will only involve the movement of pairs of electrons and therefore double-headed arrows. Now you might think that these curly arrows have just been drawn willy-nilly, but they haven't. In fact, where the arrows start and end is really important. There are only 2 places that a curly arrow can start from, and we'll use this example to show them both. Curly arrows can only start from either a bond, as is shown here, or from a lone pair of electrons, like here. Crucially, arrows can never ever start from an atom, and this is a common mistake that many students make when drawing reaction mechanisms. As with the starting point of curly arrows, there are also only 2 places that they can end. Curly arrows can either end at an atom, with the arrowhead clearly pointing to the atom the electrons are going to, as in these examples, or they can point to where a bond already exists if the number of bonds there is going to increase, like in this example, where it would go from a single bond to a double bond. Because arrows can only begin and end at these very specific places, it's really important when drawing mechanisms that you give yourself plenty of space. If all your atoms and bonds are all bunched up close together, it's going to be really difficult for you to clearly show where your arrow is starting and what it's pointing to. And if it's unclear to the person marking your paper, you will lose marks. So always make sure you draw your mechanisms nice and big, giving yourself plenty of space to fit your arrows in. And this is particularly important if you know you've got small writing. Try to get into good mechanism drawing habits from the very beginning. So we've said what the arrows are representing, and we've talked a bit about where it is they should start and where they should end. But we haven't really explained what it is these arrows actually mean. Ultimately, curly arrows are showing how and where bonds are broken and/or how and where they are made. In this example, this first arrow is showing that the electrons from the lone pair on the hydroxide ion are being used to form a covalent bond with the carbon atom, so it's showing bond making. How do I know this? Well, the curly arrow starts at the lone pair of electrons. This immediately tells me that those electrons are going to be used to make a bond. And as the arrowhead is clearly pointing to the carbon atom, they're going to be used to make a bond with that atom. But what about this second arrow? Well, this time it's showing bond breaking. Because the curly arrow starts at a bond, it means that that bond is going to be broken. The curly arrow ends by pointing to the bromine atom, But notice how this doesn't mean that those electrons are making a bond with the bromine. That'd be daft. You don't break bonds only to instantly remake them. Instead, both of the electrons are going to the atom, forming a lone pair of electrons. And this results in the formation of a bromide ion, with the bonding electrons becoming a lone pair on the bromine. Now there is a third possibility, and that is rather than showing bond making or bond breaking, a curly arrow can show both happening at the same time. If I have a curly arrow starting at a bond but then pointing to where there's another bond, it's telling me that the starting bond is being broken and that those electrons are immediately being used to form a different bond elsewhere, usually turning a single bond into a double bond or maybe a double bond into a triple bond. Even at this point, reaction mechanisms can still look quite intimidating, especially when there are lots of atoms, bonds and curly arrows all on the same page. But when you start learning specific mechanisms later in the course, don't try to understand the entire mechanism all at once. Instead, look at one curly arrow at a time and ask yourself a simple question. Where are those electrons going? If you can follow the movement of electrons one arrow at a time, you'll find that even quite complicated mechanisms become much easier to understand. So overall, reaction mechanisms are used to show how chemical reactions occur step by step, using curly arrows to show the movement of electrons during bond breaking and bond making. Remember, if a curly arrow starts at a lone pair of electrons and points to an atom, it shows those electrons being used to form a covalent bond. If a curly arrow starts at a bond and points to an atom, it shows that bond being broken and the electrons moving onto that atom. And if a curly arrow starts at a bond and points to another bond, it shows the original bond being broken while those electrons are immediately used to increase the number of bonds elsewhere, typically forming either a double or triple bond. And as the course progresses, you'll be introduced to a variety of reaction mechanisms, each detailing how specific reactions occur through the use of curly arrows, and with some even explaining why different products can be formed during the reaction. And with that in mind, in our next video we'll be looking at isomers by exploring the 3 different types of structural isomer. And as always, the full topic playlist is on the screen now.